All right, guys, we're going to go ahead and get started with our next unit here. So our next topic is going to be over inverse variation here. All right, so we do have a few examples that we'll go through and a few notes. So let's go ahead and hop into it here, guys. All right, so some essential understanding you need to know. If a product is constant, where the constant is positive, a decrease in the value of one factor must accompany an increase in the value of the other factor. As an equation, direct variation has the form of y equals kx, where k cannot equal 0. Inverse variation can have the form of many different forms. Again, you can move them around. Xy equals k, y equals k over x, or x equals y over k. Again, k cannot equal 0. When two quantities vary inversely, as one quantity increases, the other one should decrease proportionally. For both inverse and direct variation, k is going to be our constant of variation as always. So again, in any formula that we use there, k is always going to be our constant of variation. All right, so let's go ahead and look here at example 1. So for example 1, is the relationship between the variables a direct variation, an inverse variation, or neither? And then write function models for the direct and inverse variations here. So what we're trying to find is, again, as we tell here, as one increases, as we can tell here, x is increasing, y is decreasing here. So again, that's a good chance for us to already tell there's going to be some type of variation. As one increases, the other one should be decreasing here. So the way we're going to find out here is if there is a constant, all right, our variation here. If there's a constant, then we can find out what it would be here. So what we're going to do here, so you may want your calculators, I have my calculator right here, is you're going to end up multiplying all those numbers right next to each other, so the x and y. So I'm going to multiply the 2 times 15, the 4 times 7.5. I'm going to do that 4 different times. So 2 times 15, and then I'm going to do 4 times 7.5, and then I'm going to do 10 times 3, and 15 times 2. So what you should notice from here is when you multiplied all 4 parts there, your answer should have been the same for all of them. We should have noticed that that constant here is going to be 30. So since our constant here is 30, we would say that the product of each pair is 30. So now knowing that, when we write this would be written as x, y equals 30. Again, all we did was multiply all those numbers times themselves that are right next to each other. So 2 times 15, 4 times 7.5, they all came out to 30. So again, if we go back to those direct variation models, xy is going to equal 30 because remember, 30 is our constant. Now remember, we want our formulas to be in that y equals form. So for us to do that, we want it to be y equals whatever it is. So that means we have to get x away. So if I divide both sides by x, y should equal 30 over x. And this would be our model for that equation right there. Okay. There is another example of this here. All right. So let's take a look here at letter B. So same thing. Get that. Okay. So this one asks the same question. Is the relationship? I guess I should have answered that on the previous one there. So again, is this a relationship on this problem here? And then your answer should have been yes, since this inverse is variously, as we can tell here, this would be considered an inverse variation here. This is considered inverse. Okay. All right. So on the next part here. So here is our table here. So same thing as we see as one increases, the other one should be decreasing here. So from here, I'm going to do the same thing here. I'm going to multiply all those numbers times each other here. So if I were to multiply them here, I would get 2 times 10, which would give me 20, 4 times 8, which gives me 32, 10 times 3, which gives me 30, and 15 times 1.5 gives me 22.5. So since we are multiplying all those and our products are not constant, since there's not a same variable here, there is not an inverse relationship here, which means there is no inverse variation. So this one would be considered neither. So neither. Okay. All right. Example 2. I don't know why it keeps doing that. Okay. Example 2. Determining an inverse variation. So suppose x and y vary inversely, which is what we've seen, and x equals 4 and y equals 12. What functions the model here? So kind of like we saw before, we know that equation, we want to set y equals here. That equation is going to be y equals k over x. Remember from that first equation we saw when it was 30 and we said that xy equals 30. It's that same part here. This is going to be the model that we see, y equals kx here. So essentially here, we're trying to find what the inverse variation is, or our k. We're trying to solve for k here. So I'm going to plug in what I know here. We know that y is 12, and we know that x is 4. So again, to get k by itself, we're going to end up multiplying both sides times 4. So k will end up equaling 4 times 12, which is just going to be 48. Okay. So again, now knowing what k is, that model that they're going to ask for, what function model is this? It's going to end up being y equals 48 over x. That's when x is 4 and y is 12. So this is our model. Okay. All right. Example 2 continued here. So same equation. Now they're asking us a different question here. What graph of the what does the graph of this function look like? So all we would have to do, guys, is go to our y equals and literally type in 48 over x. So if they ask for a table, you can go to your second graph, right? And I should pull up the table for you. Or if they ask you to graph it, again, it's the same thing there. You just go to your graph, you can plot your points, and then just form it as you see it there. Again, you just have to understand whenever you get that model there and they ask for a graph or whatever it may be, your calculator can give you all this information here. All right. So again, make sure your calculator is nearby for this lesson because you will need it for this lesson. All right. So again, this is what your graph should look like after that model is plugged in. All right. Last part here on number 2. I don't know why it keeps doing that. Oh, so what is y when x is 10? All right. So from here, right? So we know we know what our model is going to be. So I'm going to use that same model that we've been using before. So that is y equals 48 over x. Now they're telling us what x equals here. So all we're going to do is plug in what our x is, which is 10. So y equals 48 over 10. And again, you can type that into your calculator. That should just end up being 4.8. Not too bad there. So again, make sure you know what your model is. Once you find your model, it's going to be used a lot throughout this lesson here. Okay. All right. Let's move on to the next part here. So example 3, modeling an inverse here. All right. So your math class has decided to pick up litter each weekend in a local park. Each week there is approximately the same amount of litter. The table shows the number of students who worked each of the first 4 weeks of the project and the time needed for the pickups. So again, you're in the number of students. Again, as we can tell, that number goes up. And then as we can tell in the time in minutes, that number goes down. So that's a good sign for us that as one goes up, one number should go down. All right. So our first part here. So what function models the data here, right? So all we're going to do here is we're going to see if we can find what that equation would be. So again, we're going to multiply all of this out here. So I'm going to do our n times p here, right? So I have 3 times 85. I have 5 times 51. I have 12 times 21. And then I have 15 times 17. Oops. And 15 times 17. Now understand, when I get my 4 numbers here, there are 3 that are exactly the same, and there's 1 that's really close to it. So if there's 1 that's really close to it, but everything else is the same, then we're going to go ahead and say what that constant is. So even though there is a 252 in there, there are still 3 numbers that are 255. So we're going to go ahead and say that the constant here is all relatively the same, which should be 255. So then our model here, right? Our model is going to end up being that n times t. Again, those are our 2 variables that we see right there. So n t equals 255. Okay. Again, it's just the same thing that we've seen there. There's our constant, right? Now that we have our model here, right? Again, now that we have our model, that should help us answer letter B here. How many students should there be to complete the project in at most 30 minutes each week, right? So again, now we're trying to solve here for the students part. So that means we need to get students by itself. So if I rewrite that model that we had, the NT equals 255. And again, we want students to be the variable that's by itself. So that means we want N by itself. So I'll divide both sides by T. So N should equal 255 over, and in our example here, T is going to be in 30 minutes. So I'm going to divide 255 by 30. And same thing here. Since I already have it written out, all I got to do is solve it. And again, I can type that into my calculator. 255 divided by 30 should give us right around 8.5. 8.5. Okay. All right. So key concept here. All right. Erase that little dot there. All right, so you have seen many variation formulas in geometry, some like the formula for the perimeter of a square and simple direct variations. Others like the volume of a cone relate three or more variables. With one quantity varies with respect to two or more quantities, you have a combined variation. When one quantity varies directly with two or more quantities, you have a joint variation. So the volume of a cone varies jointly with the area of the base and the height of the cone. So again, I put this on here because I think it's going to be helpful a lot. So again, so combined variations you could see, and those are formulas that you could see as well. All right. So again, know what jointly means and know what inversely means. Okay. Again, I put that up here so that you guys could really get a good look at it. If you need to pause it or come back to it, this will be helpful for you. Okay. So again, know what jointly means, and then know what inversely means. Jointly means you're multiplying by those terms. Inversely means that you are dividing by those terms. And again, you can kind of see that in those equations right there. Okay. All right, so here is another example that we can look at here. Example 4, using combined variation here. So the number of bags of grass seed N needed to reseed a yard varies directly with the area A to be seeded and inversely with the weight of W of a bag of seed. So if it takes 2 3-pound bags to seed an area of 3,600 feet, how many 3-pound bags will seed 9,000 feet squared? So our first step here, let's write our formula here. So the number of bags, so that's going to be our what we set this equal to. So N is going to equal to, remember, jointly means multiply, inversely means we are dividing by that. So again, the number of bags needed to reseed varies directly with the area A. So again, we know A is going to go on top. And then we also have our constant as well. Remember that since it's inversely, we have that constant. So there are two variables that are going to go on top, right? We have our K, which is our constant, and then we have the A, which is the area. That's what it says right there directly. Now, also understand, we have an inverse in here. Remember, inversely means we divide, and we're going to divide by the weight of the bag of a seed, which is W. All right, so remember, K was our constant, that our variation. The A was jointly, and then our inverse part was that weight or the bag of seeds there, and that's why I put for our W there. Now we're going to plug in what we know there. So if it takes 2 3-pound bags, so again, remember the number of bags was our N, so there's going to be our 2. So it's going to be 2 equals, we have the area of 3,600 feet. Remember, area was our A right there, as we can tell. So it's going to be 3,600. And then we also have what we're trying to solve for here, which is how many 3-pound bags. And again, remember, that's that weight there. So again, we're looking for 3, and then we don't know what our constant is. So we're going to put that as K. So 3,600 K, and we're looking for 3 300-pound bags. So again, that means we're solving for K here. So I got to get that by itself. I'm going to multiply both sides times 3. Right? On both sides there. So that gives me 6 equals 3,600 K. And that means now we're going to divide by 3,600. Divide by 3,600. So K should be 1 over 600. Very simple there. Now, also going back here, I've got a second page here. Right? So if we continue this, remember, we are trying to find not what the constant is, but we're trying to find how many 3-pound bags will seed 9,000 feet. So if that's the case here, if I go back to that equation that we had there, which we said was, remember, here was our equation of N equals Ka over W. Again, we now know what our constant is going to be. Remember, that constant is 1 over 600. So again, that means that 600 goes on the bottom part of that equation here. So if I rewrite this, it's going to end up being N equals, again, if you want to put 1A, you can, but 1A and A are pretty much the same thing. It's going to be N equals A over 600W. Again, K is 1 over 600. That's why the 600 is on the bottom there. Okay. So from here, understand that we are trying to find 9,000 square feet here. So that's the case. N equals 9,000 square feet over 600. And then RW, or the weight of those, there are 3 of those bags. So 600 times 3 gives us 1,800. So 9,000 over 1,800. And again, that simplifies down to 5. Which again, as we see in our answer there, that would mean that our answer is C. All right. So that is going to be it for today, guys. Again, I didn't want to overload you with too much information, but again, we are just kind of going to start with our piece-by-piece stuff here. So your homework is going to be due by Wednesday at 11:59 p.m. Remember, virtual office hours will be from 1 to 2. And if you have questions, you can always get in contact with me. All right. So again, I hope you guys had a great Easter break, and just know that I am here for you if you need me. All right, guys, take it easy.